Hi everyone! Today I would like to talk with you about most complex issues that you will face if you define your architecture incorrectly. And we can talk a lot about if something is better or something is worse, but these concrete examples from today's talk will focus really on the most important things to remember while defining it, either for solution architecture or infrastructure. Before I dive deep into this topic of the problems, I would like to define what is software architecture for me. So what do I understand from the software architecture perspective? First point is that I want to understand business capabilities and the domain itself. Then I would like to split it into subdomains and define the boundaries of it. Next things are decisions on the infrastructure level. How, where, and what I want to achieve here. Cloud or on-premise? Do I need containers, Kubernetes, API gateway, cache? What type of databases do I want to use? How do I want to approach monitoring, telemetry, or logging? Do I need some other environments than prod, or can I just go with prod itself? Then I want to define the correct deployment strategy for my problem. Would it be a single deployment unit, so you can think about modular monolith, or would it be multiple deployments units like microservices? If we decide on microservices, then we need to define our decision factors, our disintegrators on which our decision is based. Why do we want to go that way? Then I want to define the architecture of either modules in our modular monolith or microservices. And it has to be done based on the strategic analysis of a domain. Do I need an active record? Or maybe I can go just with transactional script. Or I need a domain model. Or maybe something else. Should I apply here event sourcing? Should I apply here CQRS? These are the questions which you need to answer. Next, I need to accomplish the definition of the test strategy. Which tests do I want to perform? When? How often? Here, you can look at different types of testing pyramid. In the end, I want to define the release strategy. How often do I want to do that? Do I want to do that with canary releases, with blue-green deployments, basic deployment, A/B? Do I want to release it with manual steps? Or one manual step in the end, like continuous delivery? Or no manual steps, like continuous deployments? Okay, so I told you about software architecture and my understanding of it. So what are these two main problems that you can have with your software architecture? Based on my experience, there are two options. Either your architecture is too trivial, too long, or it's too complex from the beginning. And based on selected model, you will have different issues. Let's focus first on the too trivial architecture. What does it mean? Imagine that you joined startup company and you have to deliver the software with MVP in 3 months. So this is not a lot of time, and for sure there will be trade-offs of testing, trade-offs of not designing the correct architecture from the beginning, and so on. And this is completely fine if you decide after 3 months, after releasing of MVP, that you will start continuously refactoring your application. The problem is that after releasing this MVP, you will need to deliver your features as fast as possible here. So your customers will be requiring new features and they will be reporting to you that, hey, we would like to have this or that. Additionally, your company and you as well, you will have different ideas of what you can improve in this application, and you will just focus on functionality. So all the topics around architecture will be put on a backseat and they will have to wait. How long? Sometimes it will be 1 year, sometimes it will be 5 years, and sometimes it will be never ever. So never ever in the meaning the application will end its own cycle, or the costs of maintenance will be higher than the profits that company gains from this application, and then it will have to be just stopped, or someone will decide, hey, let's build it from scratch. Not a good idea. Because of the speed of changes, you will never ever have a chance to just deep dive into the design of your architecture which you will have. If you added in the beginning a product, this product was represented by a table, so you were really data driven, not business process driven, but data driven. And you created a table with a product which has 3 properties. Then it has 5, then it has 7, 8, 15, 30, 40, sometimes even it goes up to 100. And then the performance problems start to occur in your application. And until some point you are able to optimize it. So the speed of the queries, right, will be okayish, so acceptable by users. But at some point you will just hit the wall. You won't be able to move forward because you will have huge models which will be representing the product in different contexts. Do you remember in the beginning of this episode I told you that it's very important to split your domain which you are doing on the business analysis level to multiple subdomains and set boundaries of it, because the product in one boundary can mean something completely else in the other boundary. Let's look at the part of your application that contains the catalog of products. When your user opens the page of the product, he can see a lot of different description there. He might see the name of it, the materials, the sizes, the description, and so on. But this is just one boundary. And you will have, on the other hand, a boundary of invoicing. So after buying the product, you receive the invoice. And on this invoice, probably there will be some identificator of this product, maybe a name of it, and the price. That's it. So you need 3, or maybe as well pieces. You will need here 3 or 4 different properties that are describing this product, and not the rest of 76 of them. So here you have a second boundary, second context. This is very important to remember, that if you go too long with your trivial architecture and you do not refactor it continuously and split it to modules, then it will be very hard at some point to maintain the application. What you can do if you need to speed up, because I understand it's impossible in the design phase to just go and deep dive in the business analysis. And then it's as well quite impossible after 3 months when functionality starts to grow and your customers are coming with feedback and you have ideas and so on. It's not that trivial to split it. So what you can do from the beginning is to think of vertical slice architecture, and I will link several articles in the description of this video that are describing it. If you are doing stuff in .NET, you can have just one simple project, and then you can split into folders the functionality. You can have, for example, the folder that describes accept offer, reject offer, export invoice, and so on. And you can as well group it into folders like parent folders. For offer rejection and approval, you can have offers folder, and then inside you have this approve offer and reject offer. And you can have a second folder on the root level, which is going to be named invoices, and inside you will have folder export invoice. And the logic of your code will be inside of it. Then you can as well from the beginning split this data that these folders are using to schemas in one database. So still you have one database, but you are dividing this data contexts per schema. It won't take you a long time, but already you will start to modularize your application. At the point that you need to extract it, maybe to a separate module, maybe to a separate microservice, you will already have some kind of separation, and it's way easier to go this way for such cases. What would happen if you don't go that way? So if you will follow just simple architecture and you will continue with that. As mentioned, you will have the maintenance problem. So the cost of it will just grow, And the problem is that profits will probably just fall down at some point because your users will stop using your application because it will be slow or it won't be reliable. So it will be huge spaghetti code, big ball of mud. You don't want that. But if you have it, you will probably have still a chance to hire external consultants, which are very expensive, and they will try to divide your code, your domain that you had, into different modules. And then based on that, maybe it will be possible to just bring your application back to life. The second problem is related to too complex architecture, and it's far more difficult to reverse in case we have problems there. By the time the problems are noticed, it's usually too late. The replacement of the component that we started using from the beginning is huge. On top of that, in case we depend on first or third-party services, or the worst thing, the other services are depending on us, and let's say we had deployment problems from the beginning, these problems will start to pile up. And at some point, it will be so complex to replace something in our system that we will still need the help of the external consultants, or we will have to decide at some point that we don't want to follow that way and we want to close our application. You can ask me, how the architecture can be too complex? We have a business analysis phase where we split everything. That's great. We set boundaries. That's also great. Then we decide to use this component, that component, this and this and this and that. And this is exactly the place where we fall while deciding about the architecture for the completely new product, because we don't know the circumstances in which this product will operate in a year, 3 years, 5 years, and so on. We want to bring everything up in front, so we are doing some kind of waterfall, and then based on that we think, okay, at the point that we will need to scale or so, we will just be able already to do that. And that's not the best thinking here, and I will tell you why. Imagine that you joined a company, and this company is building a new product. Here, you will have to decide what database to use, what infrastructure to do, how to structure your solution, and so on. We are often biased as software developers and software architects by conferences that we attended to, by meetups, by our colleagues, and so on. Here, the issue is that the circumstances and the problems that someone solved with this way probably won't fit well to your solution. But still you feel the pressure. Everyone talks around about microservices. So you decide that you just go with microservices from the beginning, and you don't know how many users will be there, or even worse, you know that you will have 1,000 users. And then for this 1,000 users, you are building just microservices from the scratch. So you add a huge cognitive complexity to your project and to yourself as well, because you will need somehow to handle it. You will need to learn things with your team, how to monitor, how to log, how to test, what is the fault tolerance of this and this service, about the latency, and so on. You will have a lot of different things that you won't have if you used, for example, modular monolith from the beginning. So this is the first good example. Second one, you want to pack everything into containers. That's fine. But then you just take the orchestration and you just use Kubernetes. And this is huge. This is too complex for you at the beginning. Maybe you don't need it. So there are other alternatives that you can use that are way simpler to just orchestrate your containers. Quite often, one of the biggest problems is as well that you put cache in front of your application just from scratch. And the case here is that your database is able to handle your traffic because you have just 1,000 users. Here, you need to always ask yourself, do I need it? Can I do some calculations? Yes, this is a surprise, but you can calculate your infrastructure from the beginning, even before your performance tests. and then validate it with performance tests, and you can use for that JMeter, or you can use K6 for that, or anything else that you will find. And from that perspective, you will be able to see, okay, I can handle the traffic up to 10,000 users, but when we will have like 5, 6, 7, 8,000 users, we will need to start thinking about switching something or adding this block or that or that. So this is the way to go. The most important thing here is really to start as simple as possible and then refactor, add blocks and so on. Do not start that from scratch. Don't just go for microservices, Kafka, Kubernetes, Redis cache, NoSQL databases and whatever else if you don't need it. Think if you need it. Ask yourself, do I need it? Can I do that without this block? I know it's very hard because it's way easier to just decide, yes, I heard about this or that and I want to apply it to my solution. But there are way simpler alternatives that you can do. And this is something that you should always remember. If you overcomplicate your architecture from scratch, it is as well a higher potential that your employees won't be able to get into it that fast because they will need to learn a lot of concepts that they don't know. And that's why it is very important to just start as simple as possible and then add block by block, because your team, each team member will be able to just learn about this concrete block and not about all the blocks at the same time. Other problems that you can see while having too complex architecture from scratch are the following ones. First, when something does not work, you have to check probably a lot of places. If you have a good monitoring, good logging and so on, you can easily maybe find it, because quite often it happens that it's not that easy to track. Second problem is that you don't know if the block that you added in the beginning is helping you somehow. So you added it, but you don't know if it helps you after 3 years with some issue. And it might generate huge cost, which you could save. So you could save this money that you spent on this concrete component using something else. And in the end, if you take all the blocks together, it might be that you will be able to save 70% of your costs in comparison to what you have today. Before I summarize today's episode, I would like to go with one more thing here, because I mentioned that you are able to calculate your infrastructure. And I would like to give you an example calculation. You talked with the business and there is a forecast. Forecast is talking about 10 million users, 1 million daily active users. Each user must upload a profile picture, which can take maximum 1 megabyte. Additionally, we assume that every user will do 100 requests daily, and we cover just German, Austrian and Swiss region. You might think, a lot, 10 million users, 1 million daily active users and so on. But then you start digging into and you see that this million users will probably do around 20 requests per day. Assuming that this day is 16 hours in our time zone, it's like around 60,000 seconds. If you divide this 20 million users with 60,000 seconds, it will give you 350 requests per second, around 350 requests. In the peak, you can multiply it, let's say with 3, so it will be 1000, maybe with 5, so it will give you almost 2000 requests. If you think about it deeply, you will see that the simple infrastructure is capable of handling such amount of requests. You don't need all these fancy things around. Additionally, 10 million users are required to upload the photo, profile picture up to 1 megabyte. So you calculate the most negative case, it is 10 gigabytes for profile pictures. And now imagine yourself adding this cache, adding Kubernetes, applying Kafka, for what? And with this question, I would like to just go to summary. As you can see, it's a very tough topic. A lot of things can go wrong, even if you go with too trivial architecture too long or with too complex architecture from the beginning. You might have issues with not maintainable code, with a lot of cognitive complexity, with very high entry threshold, and many other problems like costs. Let me know in the comments if you spotted such situation in your career, if you had these problems with too trivial or too complex architecture. I am really curious about it, so write comments. Don't forget to subscribe the channel to not to miss the next episodes, and hear you on the next Friday.